All right. Cool. Delay is about. All right. I'm just checking to see how long the delay is for Calgary. It looks like it's pretty long. Sweet. Awesome. Thanks, Sam. So I think the delay for Calgary might be around like 20 seconds or so. I hope that's not too bad. There's not a ton I can do about that right now. But before, hopefully before the end of the week, we get the original YouTube channel up and running again, because I got it banned yesterday. So yeah. And Sam says, if you want to test, say Sam is cool. Let's say, yeah, Sam is cool, and I'll reply to see how long the delay is. Sam is cool. Now, let me just mute for a sec. The topic today is particularly wild. Y'all are so far away from me. It's so sad. Does anyone want to move in close? Otherwise, I'll straight up lose my voice. So the topic for today is particularly interesting. It is networking. Whoa, networking, so cool. So cool. Let me make a new README file. Let me zoom in on this. Let me give you my Nima's hot networking tips. Yes, sir. Nima's best networking tips. Number one, firm handshake. Number one, firm handshake. Number two, make eye contact. Right? Make direct eye contact. That's good networking. Number three, ask relevant questions. Right? How you doing? Are you also cripplingly anxious all the time? No. So ask relevant questions. And then number four, scream occasionally. One of these is not like the other. One of these feels like it breaks protocol, right? So if these were Nima's hot networking tips, the first three are maybe pretty good. Firm handshake, most important one. Every job you'll ever get is from a nice firm handshake. But this last one here, scream occasionally, we all start to feel a little out of place and a little out of protocol. And it's not really part of the way that we interact with each other. It kind of goes against our social contract. Right? So I'll even write that down. So today's lecture is about computers. Right? We will be writing code. And I want us to put ourselves in an empathetic place, looking at the way that our computers communicate with each other, similarly to how we communicate with each other, right? And when we put ourselves into an empathetic place, we'll start, I think, really understanding the reasoning behind why some of the things for networking are the way that they are, right? Again, every time we learn programming stuff, it can be really tempting to kind of shortcut. All right, I'll just kind of cut corners in my head and go, okay, that is the way it is just because that's the way it is. Right? But you'll find that the more and more you kind of go, that's the way it is for stuff, the more it compounds. Right? And the sooner you get to a place where you're kind of anxious and frustrated and confused about the code that you're writing. We want to understand where this stuff comes from, because these things in programming languages or in computer science don't come out of nowhere, right? They don't just fall out from the sky. So to give you a basic kind of like maybe one sentence overview of what we're going to do today. So today we will explore how and why machines communicate with each other. Right? That's what we're going to do. We're going to explore how and why machines communicate with each other and how we can facilitate that communication. Right? Specifically, okay, if we're going to look at specific examples of communication, we'll look at how to make machines communicate using Node, right? Because that's the language environment that we've been working with so far. But I really want you to know that the stuff that I'm doing today is not specific to Node. Right? It's not specific to Node. And in fact, something that might be really helpful for you going forward is, if you have some time, exploring how to do the things that I'm doing today in other programming languages. Right? You might find that it's actually not that difficult. Right? JavaScript is a great language. JavaScript's awesome. Right? JavaScript gives you, all the tools that you need to build kind of dynamic and expressive programs, right? And you'll find that like your skills in JavaScript will translate pretty quickly over to other languages. Right? So for example, after today's lecture, if you're feeling particularly adventurous, maybe take a look at how to do this in Ruby, right? Because you'll be working with Ruby later on in the program. Right? So you don't have to do this today, but at some point during the program, you might find it neat to take the stuff that I'm doing today and do it in Ruby. Right? Another language that could be really good for this is Python. Right? Python could be really good. So we're going to start with, first of all, a couple questions. Question number one. How you doing? Just in general, how you doing? Good. All right. Is anyone here like not doing good? Who's like straight up not having a good time, bro? Like, is anyone here? No? All right. Nice. All right. So check in on yourself. Hope you're doing fine. Remember to drink some water. Drinking some water there. Nice. Hydro bros. Yeah. What's that? I'm doing. You know what? I'm glad you asked. No, I'm doing all right. I started watching this like Paul Rudd show on Netflix. It is very good, but I'm also very sad. I love Paul Rudd. Well, not sad with myself, but like the show is just kind of depressing, right? And I've associated Paul Rudd with like fun and quirkiness, and when I see this show, I'm like, dude, why are you doing this? Why are you doing this to us, right? Like, I have a great relationship with Paul Rudd. And actually, somehow I'm going to make Paul Rudd part of today's lecture, along with Paul Rudd's like Walmart version, Ryan Reynolds. Am I the only one who feels this way? I see you. Yeah. Ryan Reynolds is the budget version of Paul Rudd. Let's look this up. Paul Rudd. Here is the ever handsome Paul. Ryan Reynolds. Ugh. Bah. Paul Rudd, Ryan Reynolds. Right? Paul Rudd, Ryan Reynolds. They've both been in superhero movies. They both have that like comedic kind of thing going on where they're like, oh, like I'm quirky and funny. Except Ryan Reynolds reminds me too much of like people in elementary school who made fun of me, right? And Paul Rudd, reminds me of people in elementary school who were nice to me. You know what? I will just rest. I will just rest right there. Think about it. Chew on it for a day or two. Paul Rudd, better version of Ryan Reynolds. It's settled. We'll just move on. So anyways, back to coding. Keep an eye on how you're doing, but also keep an eye on how you're doing in terms of like concepts that you're picking up. Right? This is a really good time in the program to take some time and go through the basic things in JavaScript. Right? Because what we're about to do is we're about to transition from just JavaScript over to using JavaScript for things. Right? Like using JavaScript to do stuff. Right? Yesterday we learned about async stuff, right? Today we're learning about why we might do async stuff. Right? So there's going to be a bit of a divide in your knowledge. Right? There's the theoretical kind of like concepts, and then there's the mechanics of the language itself. Right? And this is a very good place to go and sit down and say, okay, how do I feel about functions? Right? How do I feel about objects? Right? Conditionals, loops. Right? Should have put arrays in here. Right? All your focal stuff. Right? Take a look at all of that, and make sure you feel fairly comfortable with it. Right? Because you're going to find if you don't feel fairly comfortable with the functions, objects, conditionals, arrays, and loops, right, you may understand the theoretical stuff that we're doing, but you won't be able to actually implement it because the language will have you stuck a little bit, right? And it's okay if you're feeling a little stuck right now, or if you're feeling a bit of friction or a bit of difficulty. Just come talk to me, right? Come talk to Travis or the other mentors, right? And we'll help you through that. But this is a very good place for you to like identify for yourself, how are you doing with those concepts? And cool. Does that sound all right? Neat. Question number 2. Question number 2. What is JavaScript? Yeah, what is JavaScript? It's a programming language, right? JavaScript is a programming language. And the thing that I always want you to focus on is language, right? Because language means communication. Right? Language means communication. And when we talk about communication, we have to think about why we're communicating with each other. Right? Often, I don't just go like, hey, JavaScript, how you doing? Right? That is not maybe useful communication for me to have with Node. Right? Node does not give me anything useful back. Right? But instead, the language is good for me to pass commands back and forth. Right? I can ask Node to perform actions. So that's why JavaScript becomes a useful language between a human and a machine, because it allows a human to easily give instructions to the machine. Right? And that's the design of the language is all centered around a human giving commands. Right? But as we look at other places where communication needs to happen, we're going to find that the language that is in that medium or is in that situation is going to be different. Right? The language is going to reflect the situation that we're in. And so when we talk about networking, right? When we talk about networking, what is the communication, right? Who is communicating? If we're talking about networking in a computer science sense. Sure. Right, it might be server and client, right? Right? Server and client might be those agents, right? And now, can you tell me what is the server and what are the client? Like what are those things? Are they people? They're computers, right? They're likely computers. So server and client might be like computers. Networking is done, in our case, between machines, right? And then something that's pretty important to see is that these are separate machines, right? I'm going to be talking about different agents. I'm going to use the word agent a lot. Generally, networking in our situation today is going to happen between agent A and agent B. And these two are separate. The only way that they can communicate is through a single line. Right? There is one line of communication that we're going to lay down. Right? For today's lecture, we're going to go with the assumption that these two agents are connected by a wire. Right? In real life, things are a little bit more complicated than that. But to get the motivation behind the protocols that we're going to look at today, we're going to imagine that these two are connected by a single wire. So to kind of give you a bit of a image, think of like a tin can telephone. Right, where a tin can telephone is the idea of two people talking with each other through a tin can, like that. Right? Maybe they're in two tree houses, maybe they're in two different buildings, and they've just set up a tin can and they can talk to each other. That's what we're going to be imagining our machines are doing. Right? So this is our medium that we're going to communicate through. Right? Over the course of the lecture, I'll draw analogies to other media. Right? For example, we'll even start right now. Can you think of a particular medium for communication that you experience on a day-to-day basis? When I'm talking about medium, it would be the place through which communication travels. The internet, sure. The internet is a medium and communication travels through there, right? Let's think even more basic, right? Right now, I'm speaking and knowledge or information is passing from me to you through airwaves, right? It's just sound, right? And it's hitting you right in the ear, right? And you interpret it. What's that? Yeah, we have to have some kind of protocol to define how that communication is happening. That's actually what we're going to explore right now, which is if this here is the medium, right? We can start analyzing the medium and understanding what kind of baggage it brings with it. Right? Every medium comes with some form of baggage. Right? For example, if my medium was written, right? If I had to write on a piece of paper and give you information, right? The baggage there is that, first of all, I need a pencil, right? I need a pencil. Then I also need paper. And then I need to physically write. So I'm slow because I need to write. Right? Then the other baggage of the medium is that I actually need to take this and walk over to you and give it. Right? And these are all things that happen as a result of me choosing a particular medium. Right? So I might have to, as the person who chooses that medium, come up with things that facilitate that communication. For example, again, if my medium is writing on paper and passing it over to you, part of what I choose to do might be to have a stack of paper so that I always have like more paper ready. Right? Another thing that I might choose to do is if I want to give you secure messages, maybe I'll also have some envelopes so that I can take the messages that I write, I put them in the envelopes, I like lick the thing shut, right? And now I've got some form of security on my messages. Right? See, I'm not thinking about computers right now. I'm thinking about communication between two agents and how the medium that I've picked actually has an effect on the way that I use that communication. Right? So if this here is our medium, right? Two people with tin cans talking to each other, what are some of the consequences, or what is some of the baggage that comes with choosing this medium? And or is this the perfect way to communicate? Sure, right? So maybe there's a distance problem, right? We need enough wire, right? We need enough wire to connect these two people together, so they have to be close enough. Sure, right? What else? What else comes out of this? That is the main one. Yeah, one has to talk and one has to listen, right? Because if both people are talking, then nobody's listening. Those messages are lost. And when you send information down the wire with the tin can telephone, if there isn't somebody to listen on the other side, your messages are lost. Right? There isn't some sort of thing that's just always listening and keeping your messages so that when somebody arrives, they can read them. Right? That does not exist in the system. Right? Whereas, if I took myself back to the writing on paper and delivering it, that medium actually does allow me to leave messages for somebody to pick up later. Right? So again, we're seeing a consequence of the medium that we've picked. Right? And here, the consequence of the tin can telephone is that the people using the tin can telephone need to use it in a particular way. Right? In fact, here, even in the picture, this person's talking, and this person here is just like listening. They're like, oh, yeah, what did Mildred say? Yeah, so Mildred hosted a tea party and I don't know, whatever, right? Like, they're able to communicate one at a time. Now, our machines are going to be exactly the same in the context of how I'm going to kind of teach you about networking. Is we'll talk about one person talking, one person listening. But I do want to shelf the discussion about machines just for a couple minutes while we go deeper into the idea of the tin can telephone. Right? what we're going to do is we're actually going to draft up a specification for the tin can telephone. We're going to draft up a document that tells anybody who wants to use the tin can phone how they can use it. And this document has to be descriptive enough that people don't have to invent their own method of usage. They'll just be able to go off of the document that we've written. So I'm going to go here. I'm going to say this is going to be the tin can phone, right? Specification. Right? This is a tin can phone specification. And we're going to find that there's multiple layers of specifying this stuff. And we've already started doing that a little bit. Right? The first part of the specification that I've made is actually describing what the tin can phone is in a physical sense. Right? So here's what you need. What you need for the tin can phone is 2 tin cans, right? A wire, or a wire to stick between the 2 of them, right? Punch holes in the tin cans, stick the wire through, right? And then just separate the tin cans over a distance. So the wire is taut. How do you spell taut? Is it like this? So the wire is taut. Right? It's just so we can talk through. And I've given a description of what we physically need to have set up to have our tin can phone exist. Right? As the description of the medium itself. And now the next thing that we might start saying is, how can you use it? Right? How can you use it in a basic sense? Right? Well, we can use the tin can by yell into one of the cans, okay, to speak. And listen to the can to hear. All right, put your ear up to the can to hear if there's any messages coming through. And this is very, very basic kind of rules about how to use this tin can phone, but there might still be some issues. Right? There might still be some issues. Specifically, there is nothing in my specification right now that says when somebody should be listening and when somebody should be speaking. Right? So if somebody was to look at this, right, if somebody was to look at the specification, set up a tin can, it is very, very likely that the people using the tin can will just end up yelling at each other and then missing messages and going like, and looking at each other and going like, are you speaking now? All right, I'll listen. And then just checking over and over again. And they'll have to come up with some kind of method of using this on top of the just yell in and listen. Right? They'll have to come up with some rules for each other. Now, I'll have us brainstorm over that. Right? Let's think about what we might do, given a tin can phone, right, to make sure that people don't talk over each other, right, to make sure that communication can happen smoothly. What are some of the rules for the tin can phone, right, that we can come up with? Rules for how to use this phone. Excellent, right? So maybe one rule is every time you finish talking, right, say over. Right? That's excellent. This way, the person who is listening knows that the other person has finished speaking. So maybe that's an invitation for them to start speaking if they have something to say. So this is great. This means that if somebody is talking, the other person does not cut them off until they hear the word over. Okay. Cool. We still ran into a problem here. What if neither of the people is talking, right, and both of them think of something they want to say at the same time? What do we do in that scenario? Right? Maybe think for yourself, like when you're on the phone with someone, right? Maybe on the phone with somebody like exceptionally chatty, and every time you start talking, they've started talking as well. What do you do? You might stop talking, right? So if you notice yourself interrupting, right, or talking over someone, stop talking. Right? That could be one way to handle this. Right? This is a thing that you take on yourself and you say, okay, if I notice that I'm talking over someone, right? And now I know that I'm saying that like the tin can phone, you can only either speak or listen at the same time, right? So maybe this doesn't even work because we're both speaking at the same time and we don't know that the other person's speaking, right? So that's also maybe a problem that we're running into, right? That could actually work really well if I have both a speaking piece and a hearing piece, right? So if you notice yourself interrupting, maybe stop talking. But this might not work because I can't talk and hear at the same time. So I'm actually going to put this down and not use that just yet. What else? What could I do? Mm-hmm. That's a great one, right? We could start a conversation and give them an invitation to let us know that they're listening, right? We could wait for them to acknowledge that they're listening, right? So I'll say, like, wait for acknowledgement before you continue, right? Does that kind of capture it fairly? Right? So I'll ask, hey, I'm about to say something. Are you listening? And then I might wait until I get a message back. Right? And maybe I'll put some arbitrary amount of time, right? Maybe wait 4 seconds to verify. Right? Wait 4 seconds for the acknowledgement. And what we're developing here is some form of handshake. Hey, I'm about to speak right now. Are you ready for me to speak? Yes, I am ready for you to start speaking. Great, I'm about to start sending a message. Are you ready? Yes, go for it. You can totally send me a message. Cool. Here it is. This is the message. Hello. Did you receive the message? Yes, I received the message. What did I send you? You sent me a message with 4 letters. Great. That is all I needed to know, right? And that might be some kind of handshake situation and verifying the messages are being sent back and forth properly. And what we might do is actually allow for some time to pass and check within that. Right? So wait for acknowledgement. I might say there's a handshake going on. Now, this might feel annoying as a person, right? Because it limits the throughput of the communication that you're able to kind of send, right? Because there's some overhead to these messages, right? But that overhead, right? That overhead is ensuring that the communication is actually happening. It ensures that those messages are being delivered properly. So these are some rules for the tin can phone. We could come up with any arbitrary set of rules, and they're all going to have pros and cons to them. Right? Here's another rule that I could come up with. If there's 2 people, person A and person B, person A can talk on even minutes. Right? Person B can talk on odd minutes. Right? I have sliced up the time, and now there is virtually no way for them to interrupt each other as long as they have a shared clock, right? If they have a shared clock or a synchronized kind of clock, then they can talk with each other. Right? And there we go. So person A can talk in even minutes, person B can talk on odd minutes. That's one thing. But now we've got this situation where what if person B doesn't have anything to say? That means person A has to wait 60 seconds, which is annoying. That is annoying, and it limits the time. So we might say, OK, instead of minutes, we'll turn this into seconds to try and lower the amount of dead time. Right? And these are things that we might have to tune. Right? What I really want you to see is the difference between coming up with rules for how to use the medium and defining the actual medium. Right? This is rules for how we can send information, just general information. And notice that in this case here, there is no, there's no emphasis at all on the kind of communication that you can send. Right? This is just generic information being sent back and forth. When you have your time on the phone, for example, say we were doing this here. When you have your time on the phone, you could do anything. You have a second, you could just scream. Just bah for a second, and then wait another second, and bah, like that's fine. And the person on the other side is just going to have to deal with it. Like, all right, I guess I'm just listening to screaming right now. Right? But, if we take ourselves back to why are we communicating, right? then we can think about how we might put extra rules on top of this to make that communication even smoother. Right? So to kind of really illustrate what I mean, I kind of very loosely just said we're going to be dealing with a tin can phone. Right? But the key issue there is I didn't say why. Like, why do we have this phone? Right? Is it because we're setting up a treehouse system and we want to have the phone to communicate to each other about, like, where we're going to go adventuring or whatever? Or like, oh, maybe this is a phone that I've set up between my house and my friend's house, and we want to talk about when we're free to play board games, or when I'm about to go to work, so we can sync up and go together. Right? We have to ask ourselves questions about why this networking actually exists. Right? I made the really silly example of Mildred and, I don't know, someone else talking to each other about somebody's tea party. Maybe this is something they do very often. So they might want to come up with shortcuts to talk about particular tea parties. Right? Maybe they have lots of friends. They might come up with code words for each one of their friends. Right? Maybe they had a really good time at a party. They might want to come up with a single letter or a single word to quickly denote that they had a good time at that party or a bad time at that tea party. Right? These are all things that, depending on the thing that we're communicating, we can encode into the language that we're using. Right? So that's what we're actually going to spend quite a bit of time over the course of boot camp exploring. And we're going to be exploring why and how the information that we're sending is formatted in a particular way. Are there questions on a motivational point of view for that? Cool. Is this making sense? Neat. So we're going to go back to our specification here and say, this was rule set maybe A, this is rule set B. We could decide on which one we want or whatever. But beyond this, we might say there's a particular format for messages. Right? We'll say, hey, you know what? If you want to use this tin can phone in order to make communication as clear and as fast as possible, you can't just say anything you want. You have to follow a format. Right? And that format might be, beyond the handshake, that format might be a title. Right? You might use let's say every message you get 5 seconds. If that was what we were going to say, like every message you get 5 seconds at a time or whatever. I know that's not what I wrote here, but we might say something like, there is 1 second for the title of your message. You might say, my title was Paul Rudd is best. Right? I might just scream that out really loud in my first second. Paul Rudd is best. So whoever's listening to the message, if they only want the title, then they'll know they can just listen to the first second. Right? And then what I might say afterwards is, this is the body of the message. Right? I might take 3 seconds. Right? 3 seconds to say something like, Ryan Reynolds is straight up, Ryan Reynolds is straight up budget Paul Rudd. Also, he doesn't even actually like Vancouver, I bet. It's all for branding. Right? I could probably say that in 3 seconds. Right? So that's my 3 second body. And then I might say that my format for my messages also has 1 second left over at the end for a sign off. Right? And my sign off might be, it's your boy, Nima, out. Right? And that's how I might say that every message has to be formatted. Right? And this way here, as soon as somebody starts listening to a message, if they don't like the title, then they can just tune out for the next 4 seconds, right? And then just come back on afterwards. And we're seeing the distinction here with the format of the message versus how messages are able to be delivered. Right? There's a distinction between this. Right? And we could and Nerali says pull the string. We could actually, yeah, pull the string is a great idea. Nerali and Calgary pointed out, and I think what you mean over there is for the rules for the tin can phone, maybe to say when you're ready to listen or you're done, you could pull the string. Absolutely, that's the thing that you could do. We're going to not physically interact with the medium here, but you totally could do something like that. That's really clever. Now, what I want us to see is that these three things that we've come up with, the specification of the physical tin can, right? How you're able to actually communicate on it in terms of like rules for when you can communicate, and then also the format of the messages. These are separate things, right? And we could choose to change each of these things, right? I could say, hey, you know what? I'm going to release a new version of the tin can phone. The tin can phone, the can now has to be triangular shaped to fit over your ear properly, right? And that doesn't change everything else about the tin can phone system, just changes the physical layer, right? Or like you saw, I could go ahead and say, we're going to use method A instead of method B, right? And then that doesn't necessarily change the format, right? I know in the way that I've set this up with the person can talk on even seconds, it kind of does. But if I did, let's say, even chunks of seconds, and yeah, like say we took a minute and we divided it into 5-second chunks, right? And then one person can communicate on the even chunks and the other person can communicate on the odd chunks. Like we can have those rules that are separate from the actual format, right? And even down to the format, we can customize the format based on the communication that we need to send. If all of a sudden I need to be able to send images over this, like if I needed to be able to send images over the tin can phone, what I might have to start doing is describing parts of an image, right? And say, okay, in the top left quadrant, there is a face. This face has this RGB value and whatever, right? I might realize that the way that I've set up my format doesn't allow me to describe images properly, right? So I might have to come up with a new format for that. So what we have here is a very, very intricate method or specification for a protocol, right? So we have a communication protocol, and this is actually more than one protocol. This is actually multiple protocols. So I'm going to call this a protocol stack, right? Because there's lots of layers to this. Right? We've got the physical layer, we've got the transportation of the messages layer, and then we've got the format of the messages layer. Right? So physical transportation of the messages, and then the format of the messages. Okay. And I have just found that right now, this is a good way for me to think about this problem. This is not the only way to think about the problem, but I think it's a good way. Right. What we're looking at here is a boiled down version of what people call the OSI stack. Right. And you can go online and look up OSI, and we'll find the OSI model. For the OSI model, the Open Systems Interconnection Model is a conceptual model. A conceptual model, meaning a way to think about this problem, right, to standardize communication functions of a big computing system. And this is how the OSI model splits it up. Right? You don't need to memorize these words at all. Right? Application, presentation, session, transport, N for network, data link, and physical. And some of these are actually going to seem a little bit more familiar to what we're actually dealing with in terms of our tin can phone. The physical layer and the data link layer, these actually build up the phone components themselves. Right? The transport layer is going to be more of the how can you actually communicate? What are the rules for transporting messages across? Right? Session layer, that's sort of like the sign off at the end, right? I'm saying like, it's Nima. And then the person who's listening to the message goes like, oh, right, it was Nima. This is part of that conversation that I was having, Right? It's not just a message on its own. It's more part of a long-running conversation. Right? The presentation in the session, an application, these things are going to get closer to maybe defining that format of the message that we were talking about. Right? Networking is a very complicated topic. You can go deep into it if you really like it. I hate it. Right? I really don't like it. But if you wanted to, you could dive in deep. It is, however, important to have this understanding of these distinctions, though, because this isn't the only place where you're going to experience this. Right? As you go forward, as you're going to be dealing with more and more stuff as a developer, I want you to start thinking about where along a layer of abstraction am I dealing right now? Right? Am I dealing right now with the actual physical thing, or am I dealing a little bit higher up? Right? And you're really going to start using that word abstraction a lot to talk to yourself about how high up the stack you are. Right? Are there questions about this? My recommendation is that you don't need to memorize the OSI model at all. You don't need to memorize it. But I would recommend looking up a video or two, right, or a little blog post, and making your way through just to see what does the OSI model mean, right, to get yourself into that mindset. And you might honestly find it very interesting. So it being 1052, what we're going to do is I'm going to transition from the tin can phone to talking about stuff that you're actually going to be dealing with. And you're going to see that it is very, very, very similar to what we just built right now. Right? Very similar. You have a little bit of a cheat sheet situation going on. There is the idea of, and where'd my notes go here? There is the idea of TCP and IP. Where did I put it? Oh, it's not in here. It was there, but it was empty, right? Yeah, this one here. No, I had a nicer one. Oh man, it's not here. You know what? Highway. Whew. There we go. I was just looking for some notes that I written earlier. So there are going to be some words that I'm going to start using in the second half of the lecture. Right now, I just want to put them in your face, right? Just in your eyeballs, and you think about them for a little bit, chew on them, right? We come back and we actually start working with this stuff. And the words that I'm going to be talking about are TCP, IP, and HTTP, right? Those are the things that we're going to start talking about. Where IP, the Internet Protocol, right? The Internet Protocol is a particular set of rules, that define how, in a very kind of loose and generic sense, you can communicate across a wire, right? We're not actually going to be working with IP very much at all. In a strict sense. You go research about this, but I'm going to gloss over IP a little bit. Right? When we were looking at, for example, that these rules for the tin can phone, this is actually made up of several rules, or several stacks. One part of this can be IP, which just defines a bit loosely how you can communicate, and then we'll have extra rules that make it a little bit more and more defined. So the analogy that I'm going to use is I'm going to say IP gives us somewhat of a highway that allows other protocols to get on and find their way to other computers. Right? So IP is going to allow other protocols to hop on. And we're going to be thinking in a highway sense right now. This means anything can get on the highway. You can put a Vespa on the highway. You can put a Tesla on the highway, 16-wheeler, whatever you want. You can put a plane on the highway, and the highway will give you the ability to go somewhere. TCP, which stands for the Transmission Control Protocol, right? We can look this up. TCP stands for Transmission Control Protocol. TCP is going to be a protocol that acts sort of like a very reliable truck, right, that gets onto the IP highway, and it allows messages to drive along the highway to the places that they're supposed to go. Right? So TCP is the truck. And then HTTP, which we will very lightly touch on at the end of the lecture, HTTP is the stuff that the truck carries. Right? That's the kind of layers of abstraction that I want you to think about right now. For today's lecture, right, we're going to be focusing quite a bit on TCP in the second half. As in, we're going to create this highway. We're going to allow the trucks to go back and forth. And we'll let the trucks carry anything for now. Right? But as you go forward, you'll see that it makes sense to think about how we structure the data that we pack into TCP. Does that sound OK? So for the next couple minutes, until, let's say until 11:08, right? 11:08, 12:08 for Calgary. Might give you an extra minute at the end just to treat you. Chew on that a little bit. Chew on the fact that IP is a highway, TCP is the trucks, HTTP is the stuff inside of the trucks, right? And really get yourself into that mindset. Right? And another thought experiment that you might want to carry out for yourself is think about beyond the tin can phone, right? Beyond that phone, what other methods of communication can you come up with? And what rules might you arbitrarily just kind of like lay on and see the consequences of those rules? And put yourself into that mindset, and that'll help a lot with the second half. Are there any questions from Vancouver? No? Cool. You're free to go. Calgary, I'm going to stay on the line for another minute in case you have questions. So I'll be right here. And if you don't have questions, Calgary, just say no. And then I'll put the stream on pause. Oh, yeah, you wanted the stuff? Absolutely. Here you go. All right. Cool. Cool. So you start up again in just a minute. So get yourselves nice and cozy, and get hyped. I am going to So I just want to ensure that the audio and the video is going through for Calgary. Calgary does have, like, again, a delay. But as soon as Calgary says that the audio is going through, then we'll get started. Cool. So Calgary, let me know when audio is going through. We just wait. Does anyone have friends in Calgary you can call up? Family? What's that? No? And Sam says good. Awesome. So welcome back. What we're going to do now is we're going to hop into writing some code. Get absolutely it's going to be great. We're going to write some code. And I'm going to try out like a tool. I'm going to be writing quite a bit of code, and I'll scroll up and down, and I don't want you to like get lost. So there is a thing that we can use. Cool. There is a thing that we can use. If I give you this link here in Slack. So this one's here for Calgary. We'll do the same one for Vancouver. If you follow that link, it'll just show you the code as I'm writing it. Right? So it's a tool I'm testing out. So please give me some like feedback if you have any. Just to check, like that should take you to a blank page that looks like this. Is that good? Cool. And then we're going to do something very special. I'm going to make a file. This file is going to be called file.js or file.txt. Right? And I'll go hello. Does that pop up for you on your thing? Dope. All right. So I'll write some code, and this way, like you won't need me to like necessarily zoom in so much. You'll like actually have the code. So here's what we're gonna do. I have talked about TCP. I've talked about networking. We're actually gonna see this in action, and you'll start really understanding TCP as I use it. Right? TCP is not really the kind of thing that I can like talk about so much anymore. We just kind of have to dive right in. So I made myself a folder. It's called TCP Simple. Not because TCP is simple, but because I'm going to show you a demo without much fluff to it. This is going to be just just the things that we kind of need to know. Okay. Now we'll make a file in here, just a quick README to write out some stuff. In this demo, we're going to explore TCP. TCP is made up of two agents, A and B, right? At minimum, two agents. Okay. These agents are going to have specific roles. Right? In TCP, one person is going to be the client, and the other agent here is going to be the server. Right? And what this means is one person is the host, and the other person is the person who connects to the host. Right? That is about it as far as the relationship between the client and the host is right now for TCP, is that there is a host, and the client can connect to the host. And once the two are connected, they can just yell at each other. Right? So client and the server, client and server can yell at each other as much as they want. They just kind of scream, and if they want to, they can listen to the other person. There aren't a ton of rules about who can speak when and all that. The only thing that really matters with TCP is that you know When you shout down the wire, it is 100% guaranteed that that message will get to the other person. All right, that's all the TCP says. When you shout down, it is 100% guaranteed that it'll be received. Now, will the other person actually listen? Will they do what you tell them to do? Maybe not, right? But they will receive the message. It will be delivered. We have a client and a server. It means the client needs to connect to the server, right? So we're going to end up writing code for both of these things, both the server who can be connected to and the client who does the connecting. And then once we've got that connection going on, we're going to send messages back and forth between the two. Right? So I'll give you an option here. We can build either one of these first, the client or the server. Which do you want to do? We'll end up doing both, but do the server first. Awesome. So we're going to do the server. And because you're the one who chose server, you're going to guide me through the entire process. Where do I start? Where could I start? Let's see. Do I have a server already? Okay, so maybe I'll start with that. What's that? So I might create a server, which might mean creating a file, which I'm going to call server.js. Okay. In server.js, if I go into Node right now, so if I go into Node and I go Node server, Node server.js, and I go enter, nothing's happened. Right? This is fine because I haven't written any code. So I'm going to go into the server file and I'm going to pseudocode some stuff out as comments. And then I will challenge you to think about how we might structure this. Right? And here's the pseudocode I'm going to write. The server listens for connections. Right? So when my server starts, I want it to listen. Right? And let's say something like whenever there is a new connection, right? So whenever a client has connected to me, just console.log something, right? Console.log a new client has connected or something like that. And I want to listen for connections, and when a new client has connected, I want to just console log. How might I write that as JavaScript? Right? I'm not saying exact kind of what are the libraries I'll use or whatever, but I'm thinking more in constructs. Like what kind of syntax might I need? Or how might I be writing some of this code? There might be a function, right? So I might need some kind of function. And what might that function kind of do? It might listen, right? So I need something that actually starts listening, right? So I might need a function that maybe says like listen. Right? Now, whoops, and not all this, but just listen. And so I might have a function called listen. And now I've said that whenever there is a new connection, I want to console log. Right? How might I get to that? Does a new connection happen immediately? Like as soon as I run the script, is there guaranteed to be a new connection like right then and there? No, it might happen later, right? It might happen some arbitrary amount of time later. And how do I, like what do I call that? There's an async situation, right? So I'm listening, and whenever there is a new connection, this is some async behavior, right? How do we deal with async? Callbacks, right? So at the end of yesterday's lecture, I said, whenever async pops up, that's a place where you tell yourself, this I'm going to deal with a callback, right? Because there might be an action. For example, let me say this is const action. And this is a thing that console.logs new connection. Right? That is an action. It doesn't need to happen right now. I need to register it for later. Right? So what might this syntax look like if I want to register that action to happen later? On something, right? On something. I might say something like on connection, right? On connection, I want to run my action. What do I do? How do I pass my action to this on thing? As an argument, right? So I might go on connection, run this action. And now, this here, like, I know there's not a ton of code here, and I know it might feel a little weird, right? I'm trying to get you to think a little bit about how we're trying to solve this weird asynchronous problem. We're trying to solve this problem of getting somebody to start listening, right? And we need to think a little bit about like how we might structure that code, right? Here's the question: who is listening? Who is listening right now? Maybe we want a server to listen, right? So I might go server.listen, right? And maybe server.on connection, right? Because I might want to attach this to something, right? I might want to have like a server object. Right? This could be one way to structure this. It's not the only way, but this is one way to kind of think about this problem. If I'm seeing this server, is there a server object right now? No, so I might bring one in from somewhere. I might go import, or not import, what is this? Server equals require, and then maybe I bring that from a place. Right? Require server stuff. Right, to then be able to deal with this. Right? Now, hypothetically, like we could actually get this code to work. Right? We sketch out an idea like this, and we take a look at it, and we say, does it do everything that we're looking for? Well, we needed something to start listening, so I have server.listen. And we needed somebody to say, whenever there is a new connection, run this particular action. I can assume that inside of the server, it's able to listen for connections. And I can assume that anytime there's a connection, so I'm attaching a listener, they run this action. Right? Now, we're going to find that the code that we actually end up writing is going to be very, very, very similar to this. Right? And again, I want you to see that like I didn't force you to write this code. This is what you kind of communally came up with from your understanding of JavaScript and your understanding of the problem. Right? And any time you pick up a new tool, right, I urge you to take yourself through the design process for that tool to understand why they made those particular decisions. Right? Why is it that we have to use this tool in this particular way? So I'm going to go ahead and I'm going to call this like brainstorm.js, because that's the one that we came up with. Right? But I'll make another one, and that one's going to be server.js. Right? And in server.js, that's where I'm actually going to write our code. So we have some modules that are already built into into Node. Let me just bring something up to that real quick. There is a module. Oops, no. There is a module called net. There is a thing called net that's already inside a Node, and we could go console.log net to see what it is. Right? So when I go node server, I get out a gigantic object with just a ton of stuff in it, among which is a function called create server. Right? So evidently, like I have access to net.create server. Right? I could try this out as it is right now, or I could go look at the documentation. And I'm just going to run this as it is. So net.create server, I'm running it, and it's not giving me an error, which is nice. Right? It's not giving me an error, and you know, I might be happy with this. Think, OK. Now, maybe I've made this server. Maybe I've made this server, and I want to think about, if I look at my brainstorm thing here, this could be the equivalent of this part here, like bringing in the server. Right? I might want to save it to a variable. Right? I might want to say something like const server equals And then this is apparently maybe going to create a server for me. Right? And I could see what happens when I go console.log server now. Right? What does that actually end up giving me? So we run node server, and it gives me, again, a giant object, but this one's slightly different. This object here is an actual server object. And a server object we can do things on. Okay? I can tell a server to start listening. Okay? Now, where do we go? Here's TCP simple. It's my server. VS Code tends to be really nice in terms of autocomplete. I'll even find that when I go server dot and then anything, it'll even start suggesting stuff for me. And there is a server.listen. Server.listen function, right? I could find this if I looked at the docs, right? I could find this just by digging through when I go dot and just scrolling. And going, okay, like what do I think emit does? Let me go look that up. The server.listen. This is going to be a function. And I'll run this right now, and we'll see what happens. And what do we notice is happening right now? It's still running. Okay, my program's hanging. This is similar to what we had yesterday. Yesterday, our program was hanging because it was waiting for text input. Today, our program's hanging because my server is listening, and it just waits. It's waiting. What is it waiting for? Nothing really. It's just waiting. It's like a very patient friend. I'm here. You're like, no, but I want advice. And they're like, I'm here. I'm always here for you. And you're like, yeah, but what should I do? I'm always here for you. That's OK. So here's my server.listen. Evidently, I'm listening. Now, when we make programs listen on a network, right, on your machine, we actually have an option. You need to find this when you go listen and you go parenthesis. It even gives you some suggestion for an argument. It says listen takes question mark means optional. So it takes an optional port, right, and that is going to be a number. Your machine is able to have lots of programs running on it at the same time. And many of those programs might have some internet capabilities. Right? They might be able to connect to stuff. And it's not fair for you to only have one program on your machine connected to the internet at a time. That's just not fair. Like, oh, I'm sorry, you can't watch this YouTube video because you also have iMessage open. Right? Or oh, you're going to have to close Slack if you want to go see Wikipedia. You know, that's lame. So instead, our programs are going to be able to register themselves on what I'm going to call a port, which is like a window to the outside world. Okay, the programs are going to say, hey, this is my window. I can do all my communication through this, and this is mine. And if somebody else wants to communicate, they're going to have to pick a different window. Okay? And there are many of these ports. Ports are just going to be numbers. In fact, if I was to Google, say, how many ports in network? How many network ports are there? There are 65,535 TCP ports. So if you pick one that someone else is already using, just pick a different one. There's not someone else in the world, someone else on your computer. Right? And there probably aren't 65,000 different programs that are connected to the internet on your computer. If there are, reevaluate. Like, maybe you don't need all of them. So we can pick any number. If we don't give it a number, it'll pick one that's like by default. I don't know what this one picks by default, maybe 80, maybe 8,000. There's some numbers that are used pretty regularly, but we can pick any number we want. Does anyone have a favorite number between 1 and 65,535? $999? All right. So we're going to listen on port 999. Okay. And I could run this now and say, OK, is it listening on port 999? Maybe. One way to find out is to connect. Okay. One way to find out is try to knock. Hi, is there anyone at 999? And if there is, then something might happen. And one way to make connections with TCP is through your browser. That's one way. Okay? I'm only going to do this as a quick demo right now, but you'll explore this going on further on. Here's what I'm going to do. When you write an address in here, it'll make a connection. All right, it'll make a request. So I'm going to make a request to localhost being my machine, 999. Right? To go to a particular port, I'm going to use colon. Right? So localhost 999, that's going to hopefully this particular program. I'll do one that's wrong first. Like, let me do 9923. I don't have something on 9923. I'm pretty sure of that. And when I run this right now, it'll tell me, it refused to connect, the site can't be reached. There's nothing there. Right? Now, I might have, we'll just keep it at that. We could try now to 999 and see if anything different happens. When I press enter, I'm going to notice that this thing right here, what is curious about that? It's trying. It is trying. It is knocking. Right? It is doing the, what was the boombox? It's doing this. Oh, no, copyright. It's doing this situation. Like, hey, I'm here, right? Like, is there anyone there? I'm going to leave this real quick so I don't get struck. So it's trying, right? And there might be someone on the other side. In this case here, there is, right? But we haven't written anything to say that when somebody makes a connection, this is what you should do, right? So that's what we're going to do last. We're going to say, OK, when the server gets a connection, and you suggested server.on, right? We could see if server.on is a thing, right? There actually is an on, right? Server on, and then I get a bunch of events. I'm going to say server on, and then the syntax that the net library has chosen is that you pass it a string. And you can say, whenever there is a connection, here is what I want you to do. Right? So I might console.log new connection. Right? Whenever there's a new connection, just console log new connection. And I'm going to restart my server. I'm going to go stop, start it again so it loads up with the proper code, the one that I just added. I'm going to go over to this page here, and I'm going to start refreshing. And I'm going to refresh a bunch of times. Right now, this is still hanging because no one ever responded. Right? No one ever responded. But with TCP, I can even just connect, and that's good enough. And what I'm going to see over on the other side is I got new connection a ton of times because there were a bunch of new connections. Cool? Look at how it doesn't take a lot of code to be able to start listening. Right? It doesn't take a lot of code. And in fact, it's very, very similar to what we brainstormed ourselves. Right? A good way to learn this stuff is to look at what the requirements are and force yourself to come up with a solution before you even look at what the tool is. Right? And you'll find that like you're actually able to do this stuff. Right? By the end of boot camp, if you wanted to, you could make your own libraries for connecting and for sending messages. You could come up with your own version of TCP if you wanted to. Right? You have the capability. Now, what I'm going to do is I'm going to switch from server. I'm going to do the client side. Right? So we're going to stop this. Although, are there any questions before I move on from here? We will come back to this, and we're, over the next 20 minutes, going to beast this up quite a bit using some of the stuff that we built, or like some of the stuff that we used yesterday with the text. I'm going to go over to the client, meaning I'm going to make up a client file, client.js. We already did the brainstorming for the server, so I won't make you brainstorm for this. But I'll take myself through this process, which is that my client needs to connect to the server. Right? And then what I might say is, after connecting, print out I connected. Right? Maybe that's what I want to do. I want to connect to the server, and then I want to print out that I connected. And I might think, OK, this could be built up by saying connect. Like connect to the server. Maybe there's a function called connect. And if I want to do something after connecting, is connecting a thing that happens immediately? No, right? So I'm going to have to register an asynchronous thing, right? I'm going to have to say when you've actually managed to connect. So I'm going to need to pass this a callback. Right? When you've managed to connect, then maybe console.log I connected. Right? Maybe something like that. Right? Or I might come up with like a different structure to this, such as this is create connection, right? So const client equals, oh wow, it just randomly imported stuff from here. I did not mean to do that. I might say const client equals create connection, if that was a thing. And then I might say something like client.on connection. Right? Like when you actually connect, then console.log I connect. Right. Now, there is some crucial information that is needed when I try to make a connection. Because when I create a server, I say I listen on this port. When I'm connecting, I need to say, OK, I am connecting to this person, to this address. So I might want to say something like create a connection to localhost 999, like we did in the browser. Right? My code is going to end up being very similar to this. Right? So I'm just going to save that as fake client. My actual client is going to be really, really similar. I will still bring in that net module. So require net. And what the net module has is create connection built inside of it. Right? So I can create connection. I can go const client, right? Or const connection, or whatever I want to name it. Then let me just check here. Create connection. To my connection, I actually need to pass in some configuration, right? And that configuration is going to look very similar to what I kind of sketched out quickly. The only thing is that this is going to say a host and a port, as opposed to being just one big string. My host could be localhost, right? Localhost on port 999. Right? Localhost port 999. And this is enough for us to try seeing if anything's happening. Right? I can go node client.js. I run it, and it got angry at me. It got angry at me, and what it says is a connection was refused at localhost 999. And I think a little bit, and I say, OK, the only script that I just tried to run was my client. And it went to go knock at 999, and then it says a connection was refused. Why might that be? Because my server's not running, right? I need to have a server running in order to have a client connect to it. So I'm going to have two terminals. Right? I'm going to have two. In one of them here, demos, simple. In one of them, I'm going to run my server. Right? So my server is running now. And in the other one, I'm going to run my client. Then I'll see that when I run my client and my server is running, it connects and it's fine. And again, what I want you to see is that it doesn't take a lot of code. Right? That's one of the really nice things about JavaScript is that I'm able to spin up this stuff with just a couple lines of code. And they're generally, if you take a look at them, generally pretty intuitive in terms of like what they're trying to do. And now I said that what I wanted to do was after my client connects, print something out. See if client.on is a method. It is. VS Code is even nice because it suggests what events I can listen to. And there is a client.on connect. Right? I can explore the other events if I want to as well. I'll say when my client connects, what I want to do was console.log I connected. Right? And now I'm going to find that whenever my client connects, it says I connected. And over on my server, whenever somebody connects, it even says new connection, right? Stuff is about to get wild. Things are about to get really wild because you're going to see that with very, very small additions to this code, we can actually build a chat app. Right? We can build a thing where you're able to send messages to me, I'm able to send messages to you, everyone can see messages with each other. And Calgary, unfortunately, this is only going to work on the Vancouver network, right? But something that you can try is like you have the code. If one of you wants to take the code and run it as the server, and then everybody else can connect to them with their IP address by replicating the steps that I'm doing, then you can get it to work. If it doesn't work, then like we can chat after lecture. Otherwise, like you'll be doing this stuff for activities today. So what I'm going to do is I'm going to say that instead of connecting to localhost, because that is my machine, I'm going to give you my IP address. Right? I'm going to go and say open network preferences. This is how you do it on Mac, but on Windows and on Ubuntu, it's going to be different. Advanced TCP IP, and then I'm taking my own IPv4 address. If you want to figure out how to do this, just Google find my own IPv4 address local, right? And that'll give you this series of numbers. So when I do this and change my host to that, I'll notice that over on my client side, over on my client side, it still works fine, right? Because instead of using localhost, it just uses my actual name. So what I want y'all to try is over in Vancouver, and I will paste this in Slack as well for Victoria, Calgary, sorry. So this is here in Vancouver. This is here in Calgary if you want to take a look at it. Or you can change the host to somebody's IP address there. Some of you are going to be able to, like here in Vancouver, some of you are going to be able to connect to my server. Right? I think if too many people connect, it might crash my server, but that's kind of funny to see anyways. Right? So you can paste that into a file and then just run it. And in a second, I might start getting new connection, new connection, new connection. Sweet, there we go. I'm getting a bunch of new connections now. New connection. New connection. Y'all are hackers. This is what hacking is. You're in the mainframe, right? You got to get your tinted glasses, your fingerless gloves, and all that. You're hackers now. Now, what we're going to do is we're going to write some code that actually lets you send messages on command from your machine to my machine, right? And from my machine to your machine. So what we'll do is I'm going to stop the server. I'm going to write a little bit of code over on my server side, and then I'll also write some code on the client side and give that to you so that you can run that again. Okay. A chat app means that messages can be sent from the client to the server, right? You can type and send messages. And then anytime you send a message, the server broadcasts that to everyone, right? So you're all connected to me. If one of you sends a message to me, I will echo that to everybody else. So I'm going to do that echoing part first, right? I'm going to code that up from the server side to send messages out to everyone. And then when you receive a message, you will just print that message out, right, as a client. So that's going to have to be over on the server side, right? What I'm actually able to do is every time there is a new connection, I actually have access to that client. Right? I have access to that new client who just connected to me, right? I can go console.log client, and what I'm actually going to see is if I'm running my server and I rerun my client, over on my server side, it will have printed out a big object that represents the person who just connected. Right? It represents the person who just connected. And what I can do with that person is I can technically go client.send. Client.write. Yeah, client.write. And what I'm able to do with write is I can actually send back some text. Right? I can go, welcome. to that client. I can send that. So whenever somebody connects to me, I am going to send them a message that says welcome. And now, right now, if I run my server, that has been loaded up. And every time I connect with a client, that message is being sent to the client now. But the client is not displaying it. Because there's nothing in the client that says, whenever I have a new message, print it out. I'm actually going to have to write that. I'm going to have to say over on the client side, client.on, and then data, right? There happens to be a data event. I can say, take that data, and maybe console.log that data. Okay? This is what I'm going to do for now. Every time there is data, my client's just going to print it out. And if I rerun my client, I will find that my client actually prints out some data that it received from the server. Now, this data here is going to be represented as what's called a buffer. You can think of this as like a binary string. All it gets back is just a 0, 1, 1, 1, 0, 0, 0, 1, 1, 1. Right? My server sent some text. It sent some text. But my client doesn't know how to interpret that text. Right? It's just random, just jammed up letters. But I can tell my client to interpret this text as text. Okay? So I'm going to bring in code that's similar to what we had yesterday that I told you to ignore. And I will also tell you to sort of ignore this again today. What I'm going to say over on my client side is I'm going to say to set my encoding to UTF-8. That's just going to mean I can understand the text that comes in as text, as opposed to being an image or some video or something like that. Okay, this is going to be some text. Right? That's one thing that I'm going to do over on my client side. And the other thing is that over on my server side, I'm actually going to have to do something similar. My server side is also going to say client.set encoding UTF-8. Again, I know that I'm pasting in a bunch of code right now, and it might feel like I've just gone off the rails. Right? This here is a demo just to kind of show you the power of networking. Right? But really, all you need to know at the moment, at the end of the lecture, is you can connect. Right? And then through the activities today, you're actually going to be going through this process slowly and building it up. So what I have now is my server says, I am going to be talking in UTF-8. My client is saying, I am also going to be talking in UTF-8. So they're able to talk to each other in a way that is human readable. So I'm going to go ahead and stop my server again and just restart it. My client, I'm going to restart that. And what I got back was, welcome. And this is wild. This is crazy. Because now I can actually send anything back and forth. Literally anything. Right? I have, at the moment, sent welcome. But I will, in a second, be able to send literally anything that you type back and forth. Right? And then it's up to you if you want to make your server or your client have extra functionality. Right? Like if somebody sends the words log out, right? Maybe log them out or exit. Right? Maybe if somebody sends in the words private message to Tom, right? Maybe that's actually going to start a private message, and you can create that yourself. Right? But I want you to see now that if somebody was to connect, and I guess some of you already have, to connect to my server, right? If you take the code that I wrote, are y'all getting welcome back? No? Well, you have it on the codecast thing, I guess, yeah. Nice. So in the last couple minutes, what I'm going to do is I'm going to set it up so that every single time somebody connects, it sends a message to everyone to say new client connected to everyone. And then after that, I'm going to set it up so that you can send in a message and it'll be echoed to everyone through text. Cool? So that first piece of functionality, I'm going to call a broadcast, I guess. You can call it echo, broadcast, just the ability to talk to everyone. So I might make myself a function, right? I might say const broadcast. And maybe what broadcast does is it's supposed to go to everybody and send a message to everyone. Here's the problem, though. At the moment, I don't actually have access to everyone. I have access to a single person at a time on the server. How could I keep track of everyone? What's that? I might store the connections in an array. I might, every single time somebody comes in and connects, I might save them, right? So that later, if I wanted to send messages to everyone, I could just go through that list and send it to everyone. So what I'm going to do is I'm going to make myself an array, const everyone. Maybe that starts off as empty. And I can say that every single time somebody connects, I'm going to go ahead and I'm going to say, sure, set their encoding to UTF-8, but also everyone dot push, right, that particular client. So I've saved that client. And then the next thing that I can do is I can actually implement this broadcast function. What this broadcast function is going to do, the way I'm going to write it right now is I'm going to say for const client of everyone. Right? So I'm looping through every client in the everyone array. To each client, write, and then a particular message. Right? Write a particular message. And I'm going to say that this broadcast function, the broadcast function receives a message that it can send to everyone. Cool? So hypothetically now, I might be able to not just say welcome, but also maybe before I push the client to everyone, I might to everyone else go broadcast a new client has connected. A new client has connected. And what you're going to find now is when I restart my server, if you were to connect, right? If you were to connect as a client, you're going to start getting a new client has connected every time somebody connects. Right? So we've got two-way communication. Right? In some cases, you're communicating to the server, and in some cases, the server is communicating to you. Right? At the moment, the only time that I'm connecting to or communicating to the server is just when I'm connecting. Right? But in a second, I'll actually write some stuff, press enter, and send. So with TCP, very much like the tin can, either person can write to the other person. Also, you notice that eventually, I think if I have too many people, I think my server crashes because I just have too many people. Oh, no. You know what this is? I don't have a case in my server for when people disconnect. So if somebody disconnects and then I try to write to that disconnected person, it crashes. I'm pretty sure that's what's going on right now. So I might, if I wanted to, I could write some extra code to say, when somebody disconnects, take them out of the everyone array. Okay, I might have to write that code myself. I'm not going to do that today, though. What I am going to do is I'm going to take a bit of already written code. I'm going to show it to you, and then I'll bring it in. Basically, what's going to happen is I'm going to bring in that standard in module, right? Const standard in. I'm going to bring that in. What I'm going to do is instead of putting raw mode like yesterday, where raw mode is you press a key and that is it. You press one key at a time. If I say standard in.resume, what this means is you can write a whole sentence and then press enter. This says only count the data when you press enter, and it takes a whole message. And so that's what I'm going to bring in. And I'm also going to say that my messages are UTF-8 so that my client and my server can understand that. And so over here, I'm going to say standard in resume, right? Set encoding UTF-8. Again, you'll be working through similar stuff to this during the assignment today. And then I'm going to do very similarly to what we did yesterday. I can say standard in on data, right? Except this data is going to be entire lines at a time, as opposed to one keystroke at a time. It's going to be a whole line. I can say stuff like, when you write some data, send that data through the client, right? Just send it through. So this is an extra little if condition that I put so that if you write \q, it just quits. You know, just like we did yesterday with the Control-C to quit, this is going to be \q to quit. And again, this is one way that maybe we could explore adding new features or like special messages, such as, for example, \personal to send a personal message or stuff like that. Right? So this here is the last little bit that I'm going to put on the client, right? And I think you have this now inside of the codecast thing. So if you want to just copy that, then you've got it. Right? We don't need to make any more additions to the client. What you will find now is when you run the client, over here, you're going to be able to write stuff and press enter. Write stuff and press enter. But the server's not doing anything with those messages. Those messages are being sent over to the server, but the server's not doing anything with it. So what I'm going to make my server do, the very, very last step here for the server is to say, hey, when the server receives some data, broadcast it to everyone. Right? And it being 12, I'm going to make you just, like y'all here in Vancouver, force me through this. How do I say when I receive some data from a client? Like, how is that a thing that I can express? So there might be an on something, right? On, and then something else, right? Now, when we've done on, we've had to attach it to something. So server.on, right? What am I going to write here? Client.on. And that's actually kind of really important for you to focus on. You don't need to understand this right now, but I want to put it on your map as something that you should look at, like after lecture ends. That I need to say that when my client sends me new data, right? Because I can attach different listeners to different clients if I wanted to. I could say that this admin, I'm listening for this particular stuff, but this other person, I'm listening for other stuff, right? I'm going to say that whenever I receive a connection to that client, I'm going to say when that client sends me data. When that client sends me data, what I'm going to do with that data is I'm going to broadcast that data. Right? Data comes in, and I broadcast it to everyone else. And now, if I was to restart my server, and I connect as a client, and I start sending in messages, I start getting messages printed out. Right? You get hey, hell, yo, right? We're getting all kinds of stuff.
But the messages are interrupted, right? If we type them simultaneously?
No. No, they're not. Yeah, hello. They shouldn't be interrupted. These should be like sentences at a time, and then just get console logged in. Right? And we've made a chat bot, or not a chat bot, sorry, a chat room, right? You can add extra functionality to this, having multiple rooms, right? Having an interface to it, right? Yesterday we made a little menu for the restaurant simulator. You can have a menu for this, right? Setting your username so that it prints out your name and also your message, right? Those are all things that we can add to this, and they're going to be like little layers that we're adding on top. And what I really want you to see is that we have not written a ton of code. Okay, this is a surprisingly small amount of code for a kind of huge amount of functionality. And so to focus on for today is that process of going through that tin can phone, right? That specification, seeing the difference between actually connecting, right, how you use the thing and what kind of messages you're able to send, those are different problems. Okay? TCP is very much you make connections between a client and a server. A server can have many clients connected. And once that connection is established, the client and the server can just chat to each other. They can send messages back and forth. Are there any rules about what kind of messages those messages have to be? No. You can send anything. You can send just 0, 0, 0, 0, 0, 0. Like, you can send that. You can send mash of stuff. Send pictures. You could send text. What you're going to explore, going forward, so not today, but going forward later on, tomorrow and next week, is formatting the messages that TCP carries to give them some actual meaning. And that's where you're going to explore HTTP. Right? HTTP is going to be the format of the message that you send. Cool? Cool. Was this useful for you today? Is there stuff that's kind of feeling like a little kind of airy, or is there anything that you want me to quickly touch on, or are you kind of good? Cool. The activities today are really fun. Calgary, Vancouver, you're both going to be doing like what we just did, except connecting to a TV, and you'll all be able to see each other interacting at the same time. It's actually kind of cool. If you run into any issues with it, they'll call up a mentor. We'll figure it out with you. Right? Have a great rest of the day. And just to be very clear, I forgot to mention this, but you as a web developer don't actually deal with raw TCP very often. This is very much of an educational tool. Right? So if this stuff feels like a little much, right, that's totally fine, because you won't actually be writing this kind of stuff in this way very often, unless you really like it. Right? And then you can dive into it a bit more. Right? So at any point, feel free to bring a mentor by and ask for a bit of clarification on what is real life code going to look like when you're working in this style of thing. Neat? Cool. Have a great rest of the day, Calgary. Sorry for the delay again. Hopefully we'll figure out the thing soon, but notes will be out very, very soon. Cool. Take care.